3-1. Today we're going to be talking about the distributive property. So we are going to be working with kind of manipulating equations and expressions and things like that to help suit our needs. So whatever we need to solve for, sometimes you're going to have to change the equation around. So we need to know kind of some rules and some properties that we can do to do that. So our first term that we need to talk about real quick is equivalent expressions. If you see in the word equivalent, you'll think of the word equal to. So we're looking for two expressions that look different, but once you solve them out, they're going to give you the same answer. So equivalent expressions are expressions with the same value or the same answer. And an example of this would be 3 times 4 plus 2 and 3 times 4 plus 3 times 2. They look different, but they're going to give you the same answer. Now let's go ahead and try to solve them real quick to see how we get the same answer. So for this problem, let's do this one first. You do 4 plus 2 first because of the order of operations, and then you'll get 6. And then you'll have to multiply 6 times 3 to get 18, because anytime you have a number besides a number in parentheses and there's no other symbol, we're assume that it is multiplication. So it's 3 times 6 gives us 18. So that's how we get 18 in this scenario. Let's go ahead and look at this scenario. This one we have to do the multiplication first because multiplication comes before addition. So we have 3 times 4, which gives us 12, and then 3 times 2, which gives us 6. When you add them together, you get 18. So those are called equivalent expressions because they give you the same answer at the end. The next term, which is really what the whole lesson is about, is the distributive property. So in order to understand this property, maybe you can think of the word distributive, think of the word distribute. So anytime you're distributing something, you're giving something to someone, you're giving the same amount to someone else. So if I was going to distribute candy in class, I would give 1 to each person. So I'm passing out 1 to each person. That is how this distributive property works. So when you multiply the numbers inside parentheses by a number that's on the outside. So what does that look like? In this first example, we have 3 times 4 plus 2, which looks very similar to what we did up here. Now what we can do with this 3 is go ahead and multiply this 3 times the 4, and then plus this 3 times the 2. So basically we're taking this multiplication number, because we know that since it's on the outside of the parentheses, we're multiplying everything on the inside by it anyways, whether we add first or distribute it. So, but we're going to be learning this property because eventually we're going to be using variables and things like that to where we can't just add and then multiply, because we won't be able to add an x with the 2. We have to simplify it in some way, and the first step to do that is by distributing the 3. So we're going to distribute this 3 to everything that's on the inside, and then it's going to end up looking like 3 times 4 plus 3 times 2. Alright, and I give you a little example with the variable here just so that you can see why it's going to come in handy in the long run. So eventually we're going to have to be solving for x, and this is how we'll simplify and then solve. So that's in the future, but I just want to kind of to show you why we're doing this, because you might think that, okay, let's just do the order of operations, it's quicker. But we're learning a property that we're going to apply later, so we are just going to practice it in some similar, like easier form, and then eventually you'll be doing it with hard stuff. So let's go ahead and look at another visual explanation for this property real quick. Alright, we are going to go ahead and look at the distributive property in a visual way. So this might help some of you guys who are better with just pictures and things like that. So what is really going on when we're distributing that 3 to those 2 numbers on the inside? What does it really look like? So we're going to look at 2 different examples that are going to give you the same answer. And we're going to be doing it from kind of the perspective of area. So we're going to be thinking of the area of these shapes. So the area of a rectangle is the length times the width. So you do the side times the length, and then you're going to get the amount that's on the inside of the rectangle. So in this first example, we joined this pink rectangle with this blue rectangle. So we just pushed them together. And in order to do this, we have to know the lengths of the width of the shapes. So the width of this shape is 4, and then the width of this shape is 2. So in order to find the area of the whole thing, we're going to have to know the entire length multiplied by the width. So in order to do this, we do 4 plus 2 first, so we put it in parentheses, and then we multiply all of it by 3. So if we do 4 plus 2, we're going to get 6, and then 6 times 3 is going to give us 18. So that's the first scenario. Now let's go ahead and look at an equivalent expression in a different way. On this one, we still have the same size rectangles, but this time, instead of together, we're separating them. But we still want to find the total area of this rectangle and this rectangle together. So we're going to go ahead and find the area of this one and then add it to the area of this one. So we're going to do 4 times 3 plus, because we're joining them together, plus 2 times 3. So then once we multiply that out, we are going to get 18. So basically, we just showed that this is equal to this, even though we are using the distributive property and it doesn't really look like we're using the order of operations, we are going to get the same answer. So this property showed us how we can multiply 3 times 4, which is right here, and then 3 times 2, which is right here and right here, to give us the answer. So these two are the same because the area is going to be the same because we have the same rectangles, but just in this example we put them together, in this one we separated them. So let's go ahead and do some examples like what you guys are going to be solving on your homework, and let's see what we get for those. Alright, let's go ahead and look at example number 1. Okay, in this first example we have 5 times 7 plus 8. Now we are going to go ahead and use the distributive property. So remember, we are going to distribute this 5 to the 7, and then we're going to distribute this 5 to the 8. Now we can do this because even when you're adding it up and everything, you're still multiplying everything on the inside by 5. So we do 5 times 7, which is going to give us 35, and then 5 times 8, which is going to give us 40, and we are going to go ahead and add them up, and we're going to get 75. Alright, let's go ahead and solve example number 2. In this example, our 6 is over here, but we're still multiplying 6 times everything that's inside of this parentheses. So we're going to go ahead and distribute the 6 to the 4 and distribute it to the 2. So 6 times 4, which gives us 24, plus 6 times 2, which gives us 12. And when we add it up, we are going to get 36. Alright, example number 3. This one has a variable, so this is when we really have to use the distributive property because we can't simplify any other way. So we are going to go ahead and distribute this 8 by everything that's inside of the parentheses. So we're going to give some 8 to the m, give some 8 to the 4, and we're going to figure out what we get to simplify it. So if we do 8 times m, we're going to write it as 8m, because when there's no sign in between a variable and a number, we automatically mean multiplication. And then we're going to do 8 times 4, which is going to give us 32. So we have 8m plus 32. Now, can we do anything else? No, because we can't do anything else because this term has a variable in it, so we can't do anything else unless we know what m is. But in this case, we do not. So we have simplified it in the most simplest form that we can. Let's go ahead and look at another example with a variable. Now, in this example, keep in mind you have a negative number, so we're going to be multiplying by negatives. So we're going to have to use what we learned in the last chapter about multiplying integers and the negatives and all that stuff to be able to solve this problem. So let's go ahead and distribute the negative 6 to the x and the negative 6 to the 5. So let's go ahead and multiply a negative 6 times an x, and since in negative 6 there's only one negative, we're still going to have a negative number. So there's only one, so we have a negative 6x. Then we're going to go ahead and multiply negative 6 times negative 5. Now remember, when you're subtracting, that's the same thing as a negative for the term that comes after it. So it's not just a minus 5, it's a negative 5. It's because we're taking it away, so it's a negative number. So negative 5 times negative 6, we have two negatives multiplied together. So now it's going to be a plus 30. So instead of subtracting, we're now adding because we multiplied by a negative. So negative times negative equals a positive. So then we have negative 6x plus 30. Now can we do anything else? No, because we don't know what x is equal to. So this is in simplest form. Let's go ahead and look at a word problem. Okay, this word problem says, suppose you work in a grocery store 4 hours on Friday and 5 hours on Saturday. You earn $6.25 an hour. So we are going to figure out how much did you earn the whole time that you worked. So you can write this in two different ways. You could either say, okay, I worked 4 hours on Friday and I worked 5 hours on Saturday, so let me add those hours up. And I'm going to go ahead and multiply it by 6.25. And then I know I'm going to get my answer once I do that, because we added up all my hours and then I multiplied it by how much I make per hour. I can also write it in another equivalent expression by using the distributive property. So if I distribute this 625 to the 4 and distribute it to the 5, then I can also get the same answer. So if I did 625 times 4 plus 625 times 5. So instead of saying, okay, I'm going to add up my hours and then multiply by how much I make per hour, I'm going to go ahead and say, okay, well, on Friday, I made this much money plus what I made on Saturday. So it's just two different ways of thinking about the same problem. So let's go ahead and add these two problems up, or multiply and add these problems up. So let's go ahead and use the order of operations. Let's do 4 plus 5, and that'll give us 9. And then if we multiply 9 times 625, we're going to have to do some work over here. So 625 times 9. 9 times 5 gives us 45. 9 times 2 gives us 18, 19, 20, 21, 22. And then we have 9 times 6, which gives us 54, plus 2, which gives us 56. So we know that they made $56.25. $56.25. Now let's see if this equation really is equivalent to this one. If it is, we're going to get the same answer. So let's go ahead and instead of doing adding first, we're going to multiply out first. So let's figure out what we got on Saturday and what we made on Friday. Friday and Saturday. So let's go ahead and do $6.25 times the 4 hours that we worked on Friday. So how much did we make on Friday? 4 times 5 gives us 20. 4 times 2 gives us 8, 9, 10. And then 4 times 6 gives us 24 plus 1, which gives us 25. So we went and made $25 on Friday. And then now how much money do we make on Saturday? So we're going to go ahead and multiply $6.25 times 5. 5 times 5 gives us 25. 5 times 2 gives us 10, plus 2 gives us 12. 5 times 6 gives us 30, plus 1 gives us 31. So we have plus $31.25. And if we add them up, we're going to get 25 cents and 6 and then 5. So did we get the same amount of money? Yes, we did. Just we did it in two different ways. So that is using the distributive property and showing that these equivalent equations are going to give you the same answer. Alright, so if you have any questions, go ahead and rewind it, watch it again, watch it from beginning to end, or watch different parts of it that confused you a little bit. If you have questions, make sure to bring those to class. Make sure you have all of your notes done. Now let's go ahead and look at a few problems that you guys are going to do on your own. Alright, you have 4 problems to do tonight. See if you can go ahead and solve them. The first one is 2 times 9 plus 1. The second one is 3 plus 6 times 4. The third one is 9 times a minus 10. And the fourth one is negative 3 times s minus 7. So those are variables in the last 2 problems. So you can't solve completely, you'll just simplify. Good luck, we'll see what you get tomorrow.